Welcome to Easy BTech. In our last session, we have seen about the structure of operating systems, and we have seen three different structures. One is simple structure, the other is layered structure, and microkernel structure, right? And we have discussed that we'll definitely have a important question in the final exam. That is, microkernel question is important in the final exam, right? Next, in today's session, we'll discuss about the processes. Now, till here, we have discussed different topics wherein we have seen that the word process have been used multiple times, right? So, what is this process? What is it exactly? What is the relationships? How many states are there in it? And what are the transitions? How are these process switches, and so on. We'll see all the topics related to process. Okay. Before going to the topic, mm, this is Jayashree and welcome to our channel Easy BTech, a guide for BTech and beyond. All right. So first, what is process? Yes. What is process? It is a program in execution. Process is nothing but it's a program in execution. Okay. Process execution must progress in sequential fashion. The program which is in execution is called a process. Now this process, it should execute in sequential form. When a program is loaded into the memory, it becomes process. When a program is loaded into the memory, it becomes a process. Now, program is passive entity which is stored in disk. Disk is nothing but your executable file, and process is active. This program becomes process when the executable file is loaded into memory. Now my program becomes process when my executable file is loaded into the memory. Okay. What are the different parts of the process? Multiple parts of a process. Thus, the program code is also called as a text session. The program code is called a text session. You can see in the diagram which is shown that we have in our memory, we have from 0 to max, and we have different partitions there wherein a few text related files are stored in text block, data which is stored given is stored in the memory in a data block, heap and stack. Now it depends, this heap and stack depends on how the process is executed in a sequential format. That data will be picked up. Okay. Now here we have seen that program acts as a passive entity. What is passive entity? Passive entity which is stored in your memory. Okay. Nothing but your disk, which is called as an executable file. So in that file, your program acts as a passive entity, and it is passive is nothing but which is kept at one place and which is not active. Okay. Now process means process is active. That is your process that which is nothing but a program is in execution. My process which is nothing but a program is in execution. That's called active state. Okay, my process is an active state. Now multiple parts are nothing but My program code is also called as text session, hmm, which is currently activity including program counter, processors, registers, and so on. Okay. Stack contains temporary data. My stack contains temporary data. And the function parameters, the stack also performs few operations like function parameters, return addresses, local variables, so on. All these are considered as a temporary data. All these are put into a temporary data. And data section contains global variables and static variables. All the global variables and static variables are stored in my data section. Heap. In heap contains memory dynamically allocated during the runtime. Right? Heap contains the memory which is dynamically stored in runtime. Right? This is about process. Next is process states. What are process states? As we have seen that process is nothing but a program and program is active. How does a program is executed? Let us see its states. Nothing but a process state. Okay. As a process executes, it changes its state. Like say first it is in a new state. It indicates that the process is being created. Okay, I am creating a document. Okay, or you are opening a browser and you are trying to access some data from a Google Drive or your search bar. Okay, you are trying to get fetch data from a browser. That's called new. Nothing but a process is being created. You are opening an application. You're opening a browser. Next, from that, you have opened a browser, right? What is the next step? You click on the search bar. That is a running state. What is the running state doing here? It's a ready state. Process running. The instructions are being executed. Instructions are being executed. Now I am trying to get the data. I am trying to search for some Wikipedia format about Abdul Kalam. Okay, I want information about Abdul Kalam. I am searching it in a search bar, right? In my browser. Now I have given an instruction that has to be executed. My part is done. What is the next state? Waiting stage. The process is waiting for some event to occur. Now I have requested something, user has requested something. My hardware has to give reply. Okay, so I am in a process is in a waiting stage for some event to occur. Next is ready state. Process is waiting to be assigned to a processor. Now it will fetch the data. My hardware will fetch the data and it is ready to display on the monitor. Okay, it will display the data on the monitor. That's in a ready state. Okay, terminated. Process will finish execution. Process has the execution has been done. The data has been displayed on the monitor on the Wikipedia. User will get all the data which is required. He'll copy paste in his document and then he will close it. That is, he is terminating the process. Okay, this is generally one process. Likewise, how many processes you do? Right, if you have to create a mini project, if you have to do a mini project, for that You will get a template, you will get some slides, you will download some slides, 3D slides, and you will apply onto it. Alignment, you will search for an alignment of the sentence. You will convert into a smart art. Okay, you will align the text, you will add some pictures onto it, you will arrange it in a proper format, and you will provide some shapes to it. Yes or no? All these are processes which are done in one process. Okay, next. How is this process state transited? Okay, what is a process state transition? How is it transferred from one state to the other? Okay, as a process executes, it changes its state from new to ready. New is nothing but start here. New to ready. In this, what happens? The process is being created and kept in ready queue. Next, from ready to running. The process is waiting for some event to occur. Okay, running to terminated. There are different options here. In case if it is from running to terminated, when the execution of process is completed, the OS terminates the process. Sometimes OS terminates the process abnormally. Okay, if it is from running to blocked, that is from running to blocked, then the process went for IO operations. It needs some input output operations to execute a process. So it will move to a blocked state. Next, from blocked to ready is the process completes its IO operation. Yes or no? Okay. Blocked to ready, the process completes its IO operation. This is about transition. Next, process control block. What happens here? What happens in process control block? Process control block is a data structure that contains information of the process which is related to it, and which is also called as task control block, because it is something, it is performing an operation of task. This is either called as task control block. Okay, in the first process state, what happens here? It specifies the process state, that is whether the state is in new mode or ready mode or running mode or waiting mode, etc. It will specify the state of the process. Next is process number. Here it will specify the number of a particular process, which process is being executed at that time. Okay, every process, whenever the user is requesting for any data or it is undergoing any program, your hardware will assign some address to each process. That will be displayed in my process number. Okay, next is program counter. Here the location of instructions to next which is executed. Location of instruction to the next executed program. Next is registers. Registers are nothing but our CPU registers, where contents of all the process which are centric registers or your CPU scheduling information, priorities, scheduling queue, pointers, all these are available in my registers block. Okay. Next, memory management. Memory management will provide the information or memory which are allocated to the process. Memory is allocated to the process. Next, list of open files. there are different files that are associated with the processes. There is no such one file. There are different files here, like accounting information. In accounting information, our CPU is used. CPU is used as clock time, elapsed since start, time limits, and so on. It will uh, give all the information about the accounting of the process. Next, IO devices. Like list of IO devices, a process may need a number of IO devices to perform various tasks. Okay, so all these blocks play a different role, wherein process states will tell the state of the process number. It will give the exact location of the process in case if the packet is lost somewhere. Then you can retrieve that lost packet using the number of the process. Okay. Program counter is nothing but it provides the location of instruction to the next program which has to be executed. Registers are nothing but your CPU registers. CPU registers contains all the process which are having a centric registers. Okay, and these are done according to the priorities of scheduling queues, pointers, so on. Memory limits are nothing but the memory management. Here, the information will be provided where the memory has to be allocated to which process and so on. Okay. Next is list of open files. There are different kinds of files like accounting information, list of IO devices. All these informations will be provided in the list of open files block. Clear? Next, context switching. What is context switching? Context switching is a process that involves switching of the CPU from one process or task to another. From one process to the another or task from one task to another. How is this done? Here, the execution of the process that is present in the running state. Execution of the process that is present in the running state is suspended by the kernel. If I have a program which is in an execute state, okay, process that is present in the running state is suspended by the kernel. Okay, and another process that is present in the ready state is executed by the CPU. Right? It is one of the essential features of the multitasking operating system. This context switching can happen due to the following reasons, like when a process of high priority comes in a ready state. Process of high priority comes in a ready state. In this case, the execution of the running process should be stopped and the higher priority process should be given the CPU for execution. When an interruption occurs, then the process in the running state should be stopped and the CPU should handle the interrupt before doing something else. Okay, or before going to another process or switching to another process. When the transition between the user mode and the kernel mode is required, then you have to perform the context switching. Okay. Here in the diagram, I have process PO, process P1. I have two processes and the operating system is acting as an interface between two processes. My process 0 is executing a program. Okay, when it started its execution, suddenly it needs some IO operations, and it was waiting. It went to an idle state. Okay, so the request has been given to OS. Here my system call will get the data from my process control block from a save state. Here all the data is saved which is related to my process of P0. I will the operating system will fetch the data. It will find out the location of the data first, and then it will reload the state from the system to PCB1. Okay, it will reload the state from PCB1. Again, even the process P1 is also waiting for its own data before the request of PO is given. So it will reload this state from PCB1 and it will give the information to process 1. Once the process 1 receives the information, it starts executing, and while execution it needs some more information, then it will move on to the save state. Here again interrupt has occurred. My process P1 also did not execute, did not complete. So it will move on to a save state PCB1, and searching is done, searching is done, searching is in process. It will find the data of PO. Again it will reload it state from PCBO. It will give the information back to PO, the information which is requested, and once the information is got, the process is executed. Okay, again after this what happens, uh, it will go back, operating system will find the data and give back to P1. After the information is got, my P1 is executed. Okay, right. Next, relationship between processes. What is this relationship between processes? Concurrent processes execute in the OS may be either independent process or cooperating process. There are two types here. First is independent process. What is this? Process is independent if it cannot affect or be affected by the other processes executing in the system. ఇండిపెండెంట్ ప్రాసెస్ అంటే ఏంటి? ఇండిపెండెంట్ ప్రాసెస్కి ఏది కూడా ఎఫెక్ట్ అవ్వదు ఎగ్జిక్యూషన్ అయ్యేటప్పుడు. ఇండిపెండెంట్గా ఉన్న ప్రాసెస్ ఇట్ కెనాట్ బి ఎఫెక్టెడ్ ఆర్ బి ఎఫెక్టెడ్ బై ది అదర్ ప్రాసెస్ ఎగ్జిక్యూటింగ్ ఇన్ ద సిస్టమ్. అది ఎగ్జిక్యూట్ అయ్యేటప్పుడు వేరే ఏ ప్రాసెస్ కూడా డిస్టర్బ్ చేయదు. ఓకే, the process that do not share any data with any other process is independent process. నా డేటా నా దగ్గరే ఉంటుంది, నేనే యూజ్ చేసుకుంటాను, నేనే ఎగ్జిక్యూట్ చేసుకుంటాను, నేను వేరే వాళ్ళకి షేర్ చేయను, వేరే వాళ్ళ ఇన్ఫర్మేషన్ నేను తీసుకోను. దట్ ఈస్ ఇండిపెండెంట్ ప్రాసెస్. ఓకే, కోఆపరేటింగ్ ప్రాసెస్ ఏంటి? ఇఫ్ ఇట్ కెన్ ఎఫెక్ట్ ఆర్ బీ ఎఫెక్టెడ్ బై ది అదర్ ప్రాసెస్ ఎగ్జిక్యూషన్ ఇన్ ద సిస్టమ్. ఇదేంటి? ఎనీ ప్రాసెస్ దట్ షేర్స్ డేటా విత్ అదర్ ప్రాసెస్ ఇస్ ఎ కోఆపరేటింగ్ ప్రాసెస్. నౌ ఐ హ్యావ్ డేటా, ఐ విల్ షేర్ ఇట్ విత్ అదర్స్. If I want data, I will ask from others. That is cooperating process. This is relationship between processes. ఒకటి independent process, ఒకటి cooperating process. Next, relationships. ఈ ప్రాసెస్ మధ్య రిలేషన్షిప్స్ ఏంటి? ఓకే, let's see. First, information sharing. Several users may be interested in same piece of information, like shared files. Now here it must provide an environment to allow concurrent access to these types of resources. ఓకే, అంటే ఇన్ఫర్మేషన్ షేరింగ్లో నా దగ్గర ఉన్న ఇన్ఫర్మేషన్ ఇట్ ఈస్ లైక్ చీజ్ ఆర్ కేక్. Cake loves, everybody loves cake, everybody wants it. This cake, if I share it with everyone, that's called information sharing. Okay. Computation speed up. Indulo, to run a particular task faster, we must break it into subtasks. Each of the subtasks will execute in parallel with others. This is possible only if computer has multiple processing events like CPU, IO channels, so on. Computations అంటే ఏంటి నా దగ్గర ఒక ఈవెంట్ ఉంది. Say for example I have a birthday party. Now what do I do? Balloon decorations ఒకరికి చెప్తాను, కేక్ తీసుకురమ్మని ఒకరికి చెప్తాను, all the beverages which has to be aligned in the plate అది తీసుకురమ్మని ఇంకొకరికి చెప్తాను, invitations to the invitees, invitations నేను చేస్తాను. So one event which is there, task has to complete fast, okay, within time. Now this task I will break it into subtasks. Okay, each of the subtasks will execute in parallel with others. This is possible only if computer has multiple processing events. అంటే ఆ computer కి CPU ఉండాలి, IO channels ఉండాలి, so on, whichever are required. All these ఉంటేనే your processing will be called as a computing speed up. This process is called computing speed up. This modularity. For cooperating between systems, we have to construct this system in a modular fashion. That is, dividing the system function into separate processors or threads. Whatever words I am using, all these words will be explained in detail. First, I was talking in the introduction of operating system or concepts of operating system. I was telling about process. I was continuously, repeatedly telling about process. Now that meaning, our word ki meaning, the process and different relations I have been seeing now. Next, ఇప్పుడు వచ్చే terminology కూడా like thread or so-called terminology is what I am using. This also will be used in the later sessions. Okay, for this, for knowing more about the threads or different types of threads and all, please do subscribe to our channel Easy BTech, which is a guide for BTech and beyond. Okay, let's get back. Modularity. Modularity, for cooperating between systems, we have to construct the system in a modular fashion and dividing the system function into separate processors or threads. Next is convenience. Even an individual user may work on many tasks at the same time. For instance, a user may be editing, printing, and compiling in parallel. It's called convenience. But I am there, I am a user. I am doing multiple tasks. Like I have, adjusted a light. I have been running my studio. I have been OBS studio, and I have been operating my PPT, and I am changing. Likewise, as I am reading, I am changing my slide. This is called convenience. In my convenience, user convenience, I am doing multiple tasks at the same time. For instance, that is convenience. Now, this four are the relationship between processors. If the processors are having such relationships, only then the function can be done smoothly, or not. There might be a process crash or a system crash. Next. Okay. Let's end till here. We'll see the next topic, services, in the next session. Thank you, and do subscribe our channel Easy BTech.